Hey, happy physics students. This video is about position versus time graphs to help you better understand how to work with them, what they mean, what kind of information they provide, and how to use them to get that information. So, position time graph basically shows how the motion of something is changing. As any graph, it has a vertical axis, which in this case represents position, so I'm using X to say what position is, and the horizontal axis is time. So you're basically plotting data of where something is at a certain time. And to help you visualize this, imagine a meter stick, kind of a weird meter stick that has kind of a zero somewhere in the middle here. And you can imagine the location of something. Let's say it starts at 0. Later, it's at, let's say this is in meters. This is at 1 meter. So at 0 seconds is here, at 1 second is here, and at 2 seconds you located it at 2 meters. So we can make a simple graph of that. That's basically what this graph means, where we plot 0, 0 for 0 meters at 0 seconds, 1 second and 1 meter, put a point there, and you got 2 seconds and 2 meters. So there's a point. And basically you get a straight line. So what you notice here is that the shape of the graph is a straight line when something is moving equal distances in equal time intervals. So this right here is a time interval. It's 1 second long. And this is another time interval. It's 1 second long. And during each one of these, it moves exactly 1 meter. So when you generate a graph from that, you end up getting a straight line. And since you're measuring positions in meters and times in seconds, the slope of that line represents, when you're dividing rise over run, you're basically dividing meters by seconds. So these units represent a speed because it's telling you how fast you're going by telling you how far you go each second. So the slope on a position time graph means speed, and it's also telling you the direction in which you're going. So in this case, your position numbers are getting bigger to the right. Let's say this direction is positive. So it's telling you you're moving in the positive direction. So basically, to sum it up, on a position time graph, and I'm going to say on an X versus T graph, the slope represents velocity. And velocity is made up of two parts. It has a speed and it has a direction. So how can you tell if it's moving to the right? Well, if you defined the positive direction as right, then plus means right. And then if it moves in a negative direction, you'll see the numbers decreasing. So for example, something like this, where you'll see that at 0 seconds it's at 2, then at 1 second is at 1. So the numbers are going to get smaller, and they're going to be going into the negative direction, -1, -2. You probably learned in math class that -2 is actually smaller than 0, but in this case the negatives just represent where it is on the grid. So think of it as moving right on the ruler or left on the ruler, and on the graph it would be like moving up on the axis or down on the axis. So if you follow this graph, the numbers in the position are getting bigger, getting more positive. So you can interpret that it's going to the right. And here the numbers on the graph are getting smaller for the position with each time. So if I put numbers here, it'll be -1, -2, and so on. That means it's moving left. And speed is the value of the slope. And that has units. So in physics, slopes on graphs mean something. And in this case, The units are meters per second, and that represents speed, the sign of the motion of and the sign of the slope. So if you have a positive slope, you're moving to the right. A negative slope, you're moving to the left. So an example would be for, if you have a positive velocity, like this, plus 3 meters per second, what that really means is that each 1 second you move 3 meters to the right. So what that looks like is basically if I draw a dot diagram at 0 seconds, here it is. It doesn't matter where you start on the ruler. Let's say here's 0 meters. You start at 1, and then at 1 second, sorry, you've moved 3 meters further. So this is 4, right? 1 to 4 is you moved 3 meters. And in 2 seconds, you've moved 4 plus 3 is 7 meters. So each second you move 3 meters. So what would that look like on a position time graph? Here's your 0, 0. At 0 seconds, you're actually starting at 1 meter. So 1, 2, 3, 4, 5, 6, 7. That's how far we got. And this is in meters. So what's happening is at 0 seconds, you're at 1 meter. At 1 second, you're at 4 meters. And at 2 seconds, you're at 7 meters. And you see that you're moving equal distances in equal times. So this is called constant velocity. And constant velocity means you're basically moving at constant speed, same speed. So that's the value. For example, in this case, it's 3 meters every second. And you're moving in a straight line. So you're not changing direction. Okay, so that's basically what that means on the position time graph. When you're moving at a constant velocity, the graph itself, the shape, looks like a straight line. Now, when you're not moving at a constant velocity, it's a little bit different and the shape changes. So for example, if you have something and you're taking a picture of it every second and its spacings are increasing, so this is 0 seconds, 1 second, 2 second, 3 second. By the way, what I'm drawing here are dot diagrams, and they're showing you that where the object is at equal time intervals. So this is 1 second time interval here and another one here. And you can see that it's moving a lot further in the last time interval than when it started, which means it's covering more distance during that 1 second. And that means it's going faster. So how would that look in a position time graph? Well, if I do a quick plot, basically the way I can think about it is if I think slopes are speeds, then I can sort of sketch it out that during the first second, this axis is time here, and I have 3 seconds. During the first second, it's moving slow, so the slope is kind of not that steep, right? Then during the second second, it moved faster, so the value of the slope increases. And then finally, during the third second, it moves even faster, so the slope is really getting bigger. And I know I drew kind of straight lines here just to show you, but I want to emphasize that slope means speed and direction. And that's basically velocity. Okay? So in this case, it's moving to the right, so the position numbers are increasing. So here would be 1 meter, 2 meter, 3 meter, this is in meters, 4 meter. And you can see that because it's accelerating or speeding up, in this case, and moving to the right, you're not seeing a straight line anymore. You're seeing a curve. So we can use the same reasoning for showing how it would look if it's slowing down. So, for example, slowing down means during the first second it covers a huge distance, let's say, and then it kind of during the next second it covers less, and then during the next second it covers less. So that's your 0 second, 1 second, 2 second, 3 second. It's like imagine if you're taking a strobe picture of um, of the motion and you're just lighting it up where it is at that 1 second, and then one other second passes and you light up your strobe light and bam, it takes another picture. So what would that look like? Well, it's still moving to the right, right? We're calling this direction right. So my numbers have to get higher as my graph um, changes with time. So in this case, I know some students like to say the graph is going up. Yeah, it's going up, but what that means is that the position numbers are increasing. It doesn't have to be positive or negative. It just has to, yes, it has to go up in this case. So what does that mean? Well, if I do my time intervals again, 1 second, they're equal, 2 second, 3 second. During the first time interval, I have a really steep slope because it's moving fast. During the second one, I have less of a slope. And then during the third one, I have even less of a slope. So you end up seeing this kind of shape, kind of a bowl down shape. There's a bowl. You don't see this part because that would mean actually going backwards. You just see this first half of it. And here you see a bowl up shape to represent speeding up. So what we've basically just done is moving to the right, and also two variations on that. This is the speeding up variation, where the distances each second are getting bigger, and this is the slowing down variation, where the distances each successive second are getting smaller. Okay, so now we're going to take a look at what this is moving left. So moving left, we have something starting on the right and moving toward the left. It's like writing in a foreign language. So again, you start, at 0 seconds over here, and you're moving to the left, which is your negative direction. 1 second, 2 seconds. So what am I drawing here? I'm trying to draw them equally spaced. If they're equally spaced, that means I'm drawing constant velocity. So what that means is it has a constant speed and it's going in a straight line. So what would that look like on this graph? Well, that means that the slope is basically constant. So here's 0 seconds, 1 second, 2 second, 3 second, and it's going to start somewhere, and its position numbers are going to get smaller. So it'll be a straight line. Students would say going down on the graph. Yes, it's going down. The way you say that in physics language is the position numbers are decreasing. So if this was 3, this is 2, this is 1, -1, -2. The position numbers are decreasing. What that means is on the meter stick or on your coordinate system, you're basically moving to the left in the negative direction, and this is the positive direction. Okay? So moving left, your graph looks like it's decreasing on the axes, and for constant velocity, the shape is a straight line. So again, we can use our previous reasoning for what would speeding up look like. Sorry, I have a cold. And what would slowing down look like. So let's just draw these cases. So speeding up, you start off having small spacings between the dots, which means you're traveling not as far each second. 0 second, 1 second, 2 second, and so on. Spacings get bigger, which means each 1 second time interval, if you're going further, like here you went farther than you went here, and the same time passed, you're going faster. Only this time you're going to the left, right? So that's why I'm putting my 0 second here, and my time instants are labeled kind of backwards. So what does that mean on this graph? Well, the graph is going to be decreasing its position numbers. And let's think about what's happening to the slopes here. So the slopes, if it's moving slow, that means it's kind of flattish, like not really that big a slope. And then it gets a little steeper and a little steeper, and bam, you have a bowl down shape. So this is moving left and speeding up. Again, the slopes are increasing, so you get this kind of a shape on a position time graph. And for the moving left slowing down, that would mean you're starting off with big spacings. Notice my time is going backwards here. And the spacing between the dots is going to get smaller. So you can infer that, okay, it's slowing down because in this second it didn't go as far as it did in this second. Here's my position time graph. Again, I have equal time intervals, but my slopes are not going to be the same on average during each interval of time. So here it starts off real steep, bam, and then it's not as steep, and then it gets even shallower, so you get this kind of a bowl up shape. So this is moving left, slowing down. So let's review what these shapes can look like on a position time graph and what they mean. So here's a big old position time graph right here. I'm going to put everything on it. So first of all, we can have graphs that look like this, right? I'm going to put them. What does this mean, right? So these are straight lines. So straight line means constant velocity on this graph. That means the value of the slope, right, is the speed. And if the position numbers are increasing, the sign of the slope is the direction. So I don't have any numbers here. That may confuse you, so you may want to write some numbers in for yourself. And you notice that for all these graphs, what's happening is you're moving in the positive direction. So the positive direction is this way. So even if you started at a negative number, you're becoming more positive as you go. So all of these graphs represent moving to the right. And they also represent constant velocity. So it doesn't matter where you start, as long as the positions are getting more positive, you're moving toward the right on a ruler, and you have a constant velocity. So now let's do the case where you're moving left with a constant velocity. So my position numbers have to get smaller, so I'm going to have to become more negative. So I can draw a graph like this, like this. The slopes don't have to be the same. I can do anything I want. All of these graphs, so let's say this is right, moving right. This one I drew is left, because the position numbers are decreasing. See, they're getting smaller as I follow this graph. So moving left. Okay, and all of these are constant velocities because they're straight lines. And the way you find the value of that velocity is you do the slope. So let's say that this rise was 10 meters, right? Because meters is on the y-axis. And this run is like 2 seconds, let's say. Then you would do, the slope of that would be rise over run. So that's the speed value. The speed is 10 meters over the run, which is 2 seconds, or 5 meters per second. And it's a positive slope, which means it's moving right. So again, if I do the slope of something like that, let's pretend I know that this time is 2 seconds right here. This is the run of the line, and this is the rise 1, 2, 3, 4. Let's call it 4 meters. Like this distance here is 4 meters, 2 seconds. So I can actually find the speed of this thingy here. Speed is rise, which is 4 meters over 2 seconds, or 2 meters per second. But I gotta be careful because this slope is negative, and I gotta be real with that. So I'm gonna put that negative sign right in there. All right, so, and let's do a quick summary of the curvy graphs. Again, curvy graphs don't mean constant velocity anymore. They mean acceleration. So that's how you know the object is accelerating. So let's say if I have something moving to the right and speeding up, let me call it SU here. So remember, speeding up means, so first of all, right means position numbers got to get bigger. So it doesn't matter where I start as long as I'm moving in the positive direction. So let's say I start here on in the negative side of the ruler. This is negative 10 meters, okay? What this means when you're speeding up is that your slopes start shallow and they get bigger, so you end up seeing a kind of a bowl-up shape. This is speeding up right, okay? Now let's do slowing down. I'm going to call it as D here. So slowing down, again, it doesn't matter where I start, but I have to be moving right. So let's say I start here at 5 meters. It's my starting position. And if I'm going to be slowing down, what that means is that I'm going to start with steep slopes. That means fast. And eventually curl down like that. So that's really my moving right, slowing down graph. Okay, now let's do the left version of this. What happens when you're moving left? When you're moving left, your positions are decreasing. So my shape, my graph is going to have to decrease as time goes on. It's got to go down on the y-axis. So if I start here, let's do the speeding up case. The speeding up case means that you start kind of with shallow slopes for each time interval, and then you increase your slopes. So yeah, you can see that you're going to end up, if you do a careful graph of a smooth acceleration, you'll get something that bowls down like this. So this is speeding up left, right? Left, right, left, right. Okay. And slowing down, how would slowing down look? Well, I know I got to be moving left, so I got to go down on my graph, which means position numbers are decreasing. And I know that slowing down means I start with very steep slopes. I'm going to start here on this position, let's say -1. And then I'm going to slow down from that, so my slopes are going to keep getting flatter and flatter, so I get this kind of a bowl-up shape. So I'm going to label it slowing down left. So this is a summary of all the shapes, and you may be given complex graphs where you have different kinds of shapes going on. Like for example, you may be asked to interpret what's going on a position time graph where you have, let's say during one time interval it's doing this, then it has a straight line, then it's doing, let's say this. Okay. So let's just take a look at what's going on with this guy here. Again, it looks like it doesn't have any numbers. It helps me to put numbers in if I'm just learning this stuff to kind of know what I'm talking about. So yeah, I'm moving in the positive direction if my graph is going up. So I'm moving to the right. You can even put like right here, left. And by the way, there's nothing sacred about calling positive right. It's just when you're learning this stuff, it's better to kind of learn it simple and then go from there. So what's happening in this segment, let's call it W, X, and Y. So we have like 3 different segments to the motion. I know this is moving right, so I can say this is moving right. And I know its speed is not constant because it's a curvy line, but I have to decide whether it's speeding up or slowing down. So I'm going to check my slopes. I'm going to draw a slope here, kind of a slope touching this part of the curve and a slope touching this part of the curve. And I notice that my slopes are getting steeper as I follow this curve. These, by the way, are called tangents, where they touch the curve at like one place. Um, this is simple physics, so we're not getting into what that means. For some of you, this will be the velocity at that instant, approximation of the velocity at that instant. But in any case, you're noticing that the slopes are getting steeper, so that means that the speed is getting higher, so it's speeding up. And then for this guy here, this girl, it's a straight line, which means constant speed, right? Right away, I know that. The position numbers are increasing, so we went from 2 to 3 here in a positive direction, so it means it's moving right, and it's constant velocity. Velocity, remember, incorporates both direction and speed, so it's moving to the right at the same rate. And here what's going on is you notice that the numbers on the graph, the position numbers, are decreasing. So I know that this isn't going to be moving right, this is left. And again, it's curvy, so it's not constant velocity. It's definitely changing its speed because the slopes are not the same throughout. So I'm going to draw a few tangents here. They touch one point. If you don't know how to draw a tangent, draw a line that touches the curve at one spot and make these distances here equal. That's a nice little sweet tangent right there. That's a good one right there too. But in any case, what you're looking for is what's happening with the slopes, and you can see that the slopes are getting steeper. So it's moving left and speeding up. There we go. So there's an example for you, and hopefully that'll help you with your homework or whatever else you may be doing.